Welcome to CompTIA Private Limited, e-learning program of hardware and networking. We are going to see about processor technologies. So processor means it's CPU, which is heart of your computer, and it is controlling the overall operations of the computer. So it gets the input from the input devices, it processes it, and delivers to the output unit. So it has a control unit which is giving the directions to the um, different devices available in the computer, right? So you can call it as a heart or brain of the computer also. So it has communication between memory and the other units of computer, and the unit is decide the circuits to be activated for executing different instructions. Yeah. It is also coordinating with other units. So in a computer, you'll have different control units. So for controlling input and output, you'll have a separate controller. For controlling sounds, you'll have sound controller. Network, you'll have network controller. So as a single processor CPU, it is having a communication with all the other controllers and ensures that it is processing all the requests and giving the output. So it will be working based on the priority, request handler and other stuff. So based on that priority, it will process the request and gives the output. So basically, it is having a arithmetic logic unit. It is known as a logical central processing unit in the CPU of the computer. So with the help of arithmetic logic unit, it is performing the mathematical operations. So wherever we get calculations or mathematical operations, it will be performed in the arithmetic and logic unit, ALU. We call it as a ALU. So because of the advancements, a lot of things are integrated with the single CPU. So this processing unit is a single IC, and this forms a central data processing unit of any computer. The processor used in computer is also known as microprocessor due to its smaller size. So we call it as a processor or microprocessor because the size is very small. Earlier it was big. Now with the advancements in technology, I think now the size is 2 inch by 2 inch, right? So that much small it has become. Earlier it was 2.5 or 3 inch size, but now it is reduced, come to 2 inch or less than that also. So due to different transformations, right? So the new processors are more compact. The advancements in technology, the processors have become compact. So the heat dissipation is also reduced and the processing efficiency is increased. So we also saw in previous slides like processor also having a memory controller unit inside the IC. So it becomes easy for the processor to communicate with the memory controller and then to the memory, actual memory. Okay, this has direct control with registers, instruction decoders, data bus, address bus, and ALU and cache memory. So each component of the processor performs a certain function. So inside the processor, you will have a lot of segments. Each segment has its own responsibility. So normally it will be performed via registers. The register stores different data like variables or location address data, etc. So registers are playing major roles in the processes, and instruction decoders decodes the instructions for executing them. Whatever information it is receiving, the decoder will be executing the instructions right from the registers. So different arithmetic and logical operations are done by ALU, arithmetic and logic unit. So if you take the control unit, so cache memory basically act as a data repositories for storing frequently used data and instructions, thereby enabling the speedy access. So along with the ALU, you have cache memory also we have to see here. So normally cache memory, which is storing the data temporarily, and it is also a volatile memory. But this cache memory is going to help the processor to perform the activity. So instead of going and accessing the data from the DRAM or DRAM which is connected separately at 16 GB or 32 GB. So what processor does, whatever information is required for his requirement, it will keep it in the cache memory, so it can easily access it from the cache memory itself. Then once the activity is completed, that will get vanished and new information will be fetched from the memory. So that is the usage of cache memory. So as we are increasing with the technology and the quality of the pictures and data, so definitely we need to have increased cache memory size so that it can accommodate more transactions and you can get the output easier. Otherwise, you will see slowness in picture while the picture is high definition picture is downloading. You will see a form of lines available, right? So it cannot download in a single stretch. So it will get slowly downloaded line by line, and you will see you'll be able to see it in the screen itself. So but the increased processor speed cannot be fully utilized as the time to access data and instructions from memory cannot be increased. There are some limitations, right? So processor speed is high and 1.2 gigahertz or more than that. Memory clock speed is not that much equal, right? So it is not matching completely. So you cannot get the complete benefit of the processor. And one more thing here is, even though you have good processor and memory, if you're not having the address bus, that is the FSB, front side bus, which is in the motherboard, if not with the high frequency, high clock speed, then there is no use of having high-end processor and memory. So we need to have proper motherboard design so that it can transfer more number of data from your processor to cache memory or processor to normal memory, whatever it is. So this plays a very important role. So cache memory is a small memory which stores instructions, data, and immediately computed values. So here we are seeing the picture like how CPU is interacting with the cache memory and the main memory. So for immediate access of CPU, the cache memory is available. The size may be different. Okay, right. For each memory, the size may be different. So for the immediate access, we call it as L1 cache. Then the secondary level is L2 cache, and third is the L3 cache. So after traveling all these places, it goes to the main memory, that is your RAM. For RAM, it takes the data from hard disk. Suppose when I open a Word file from hard disk, so what happens? It is opening a Word file. It is getting loaded into the RAM, dynamic RAM, and slowly when I start working on the particular file, the related informations are moved on to a different cache memory. So it will be kept a link or a minimum information will be kept in the L1 cache. So whenever the processor access that file, you'll be able to see the full content immediately. It will not show you any difference in the downloading. So it helps in faster processing of um, data instructions. So larger cache memory. So if I have more cache memory, will it help? Yeah, definitely it'll help, but the motherboard has some limitations like cost. So if you have more cache memory, then it'll be more costly, right? For example, you take a mobile phone. So a mobile phone with 1 GB RAM and 4 GB external RAM, that is additional RAM, will charge you like 5,000 rupees or 6,000 rupees, normal Samsung or any other brands. A phone with 2 GB or 4 GB plus 16 GB, 32 GB. So when the internal memory is increasing to 2 GB or 4 GB, automatically the rate is also getting increased. And parallelly, they are also increasing the camera quality size. So these memories are very costlier. It's a static RAM, right? So it is costlier, and we have some limitations in using this particular memory. So for that purpose only, we also have dynamic RAM, which is also storing same kind of information. But only thing is, it will be slower than your cache memory, and it is not nearer to your processor for easy access. So via cache memory only, this memory can be accessed. So in earlier processors, the cache memory was kept at an external. I mean, it will be kept in the external of the motherboard. So processor need to process it somewhat. It took some time extra for accessing the data from the cache memory. So in later designs, what they have done, they have moved part of the cache memory to the inside the processor. So now the processor has faster access to the cache memory. So it did not travel for the motherboard and find out right and for the cache memory. So since it is internal, all the information will be captured and it will be having faster transactions. So that is the difference between external cache and on-die cache or otherwise internal cache. So, we started getting the internal cache in the processors also, and we have seen a lot of improvements in the process. So new processors are having extra buffers which can help in increasing the performance of the systems. So the cache integrated with the chip, right? Which is matching the clock speed of the processor. So it will have faster transactions. When we transmit the data via FSB, it will be flowing like anything like with higher speed. So when you have good quality of FSB and cache memory, definitely processor transactions or processor speed can be matched with other components. Clock speed. So what is a clock speed? Several features are associated with the processor and different factors affect its performance. So processor, if you take, there are different parameters. Okay, so frequencies, clock speed, and other various parameters. The way of communicating with the peripheral components, how we interact, and how we send and receive the data from the interface devices. Okay, so there are a lot of parameters available to judge the performance of a processor. But for a layman to understand that this processor is good, high frequency range available, and it will give best performance. So what we used to do is we measure it by speed, megahertz or gigahertz, whatever we have speed, we'll measure it and we'll justify that the processor is having a higher speed. So one particular parameter is your clock speed. So it is number of operations that can be executed per second. Clock speed is number of operations that can be executed per second. The unit of clock speed is in hertz. Okay, so it's a frequency, right? So we call it as in hertz. And see, for executing the instruction, CPU requires a particular number of clock cycles. It will be defined for each processor. It will be different for each component. So we have to see it and match it. If we are having the unmatched component, then functioning of devices will be not good as expected. So applications can run faster and better when faster processors are used. Earlier processors were having speed indicated in units of megahertz. So we started measuring the speeds by mentioning the megahertz. Now the speeds are increased, right? So we go for gigahertz. So 1.2 gigahertz and more than that we have in the market. So the comparison is also provided. Megahertz is equal to 1 million hertz. Gigahertz is equal to 1 billion hertz. So that is the difference between your megahertz and gigahertz. So processor development. So in the industry, so we are seeing how the memory is playing a main role with the processor, and how we started using the devices. So processors are manufactured by different companies. So Intel is the main company, and AMD and other competitors also. So what they will do while manufacturing the processor, they ensure that the features are met which is given by the competitor, and apart from that I am also adding additional features in the system in the processor, so that it can be easily sell in the market. So earlier we started with 4004 in 1971. Later we started slowly 80, x86, 286, 386, 486, like that. We brought in a lot of versions. So 8088 chip is the first processor chip used in home computers. This is very old information, so we may not find it in the current status. So moving on to next slide. Researchers have continued the research. They are not happy with the approach what we have provided in the earlier stage. So now they have come out with different technology, and we started getting 82, 86 and 386, etc. With the 16-bit chip and made available by Intel by 1982. So 1982 we started getting the kind of processor chip. So after 3 years we started getting 380, 386, which was 32-bit chip. Earlier it was 16-bit, now it is 32-bit. So another processor known as Intel 8486, what is released in 1989. This was more powerful than the previous ones. So because it was handling the very important operations at that time. So 486 was a 32-bit chip only. So after 486, we started with 286, then 386. Now it is 486 with 32-bit. We started getting advancements in the processor. Then we got a 64-bit processor from 2001 itself. That itself is got 20 years now after that was identified, right? So each processor came out with the different functionalities and different added features. Like if you take Samsung, they released lot of new model phones. With the previous model, what is the difference they are introducing? They will mention it. Apple phone also. So Pentium processors were released in the market with Pentium 1, 2, 3, 4 and all. Later they marked as Pentium M for mobile access related systems, mobility related systems. And computer processors are also made by AMD. Is a best competitor for Intel. So they released processors like AMD Athlon, AMD Semtron. Uh, Initial stages it was having uh, processor heating issue. Now that has been rectified with the programming knowledge. AMD processors are also evolved through different stages, but we have not shown here. AMD Athlon processor released with 30-bit operation, and later they released with the 64-bit processor. So apart from Intel and AMD, another processor chip manufacturer available as Motorola. So Motorola was not become famous or not used by many of the residential customer or corporate customers, but still it was being utilized by some of the team of people. So Motorola processors. So mobile processor released by Intel is named as Centrino and Atom. So Centrino is released for mobiles and Atom processor designed for laptops and notebook. So this is the interview based question. So what processor, what interview? So we have to note it down. So we had Centrino processor, and later they released Atom for laptops and notebooks. So AMD also released a processor for mobile, which is called as Thurian. It's a low power consumption, high efficiency processor, and it was a lot of thing used in um, mobile devices. Math coprocessor, yeah, to perform intensive computing types of operations in early computers. Another processor was added into the motherboard, and that we call it as a coprocessor, math coprocessor. For example, 286 is the processor used for managing the operations, whereas I will have another coprocessor as 8287. So that processor will take the data from your uh, computer and I mean the main processor, and process the data, the mathematical calculation, everything will be pushed to the coprocessor. So by that way, when we are processing as two, and we are reducing the time required for solving the overall issue. So now we are not able to see separate processor as a coprocessor. Instead, what they have done, they have added virtualization in the processor so that it is connecting together as virtually and functioning on the system. So you, for example, quad core, multi-core, all those things are like that. So here it is given list of history of microprocessor. You can see number of 8-bit, 16-bit, and 32-bit, 64-bit also. So these are all the processor family, starting from 186 to 86 till AMD Radeon available in the market. So Pentium processor, if you take the latest one, i3, i5, i7, so these are the latest processors available. So we come to the conclusion of part 1 of this particular video. We'll continue with part 2 in next slide. Thank you.